Scientists believe there are millions of wayward black holes throughout our galaxy, the Milky Way. And because we can't readily see them, one could be right next door. So how close does something have to be to get sucked into a black hole?
Too close to a black hole is about the distance between the sun and the Earth, but that is certainly too close.
For future space travelers, death by a black hole would be a violent way to go. The method by which a black hole could kill you depends on how big the black hole is. They come in two categories. Most of them are the stellar mass black holes, which are 5 to 30 times the mass of our sun.
If the black hole is stellar-sized, then the tidal forces near the black hole are strong enough that it will tear you apart tidally, even well outside the event horizon. If you wanted to fall into a black hole, you certainly wouldn't want to fall into one of those. It will spaghettify you.
But in addition to the stellar-sized black holes, there are others that are mammoth, millions to 1 billion times the mass of the sun. And now scientists believe that these monsters hold center court in every galaxy, including our own. Black holes. They're one of the most mysterious and potentially dangerous oddities in space. A black hole has a ravenous appetite. It sucks in everything in its path and spits out what it doesn't devour. And now scientists have discovered there are supermassive black holes, which are millions of times bigger than their stellar mass cousins. And evidence suggests that supermassive black holes were born after the Big Bang, when the universe was first created.
The leading idea is that they would have formed just like a stellar black hole from the collapse of the core of a massive star. But then they grew by feeding grossly from the gas, from other galaxies which collided with them.
Scientists have discovered that these black ogres wield their power in the center of galaxies.
The supermassive black holes are at the center of the galaxy, most likely because they're the most massive object within the galaxy. Massive objects tend to sink to the middle, so you'll always find them at the center of a galaxy.
For a long time, scientists didn't think a supermassive black hole existed in our neck of the universe, the Milky Way. But in 1995, astrophysicist Andrea Ghez set out to prove one exists.
We've done an experiment over the last 10 years to ask the question, is there a supermassive black hole at the center of our galaxy? And the way we did this experiment is to use the motions of stars at the center of our galaxy to test whether or not there's a large amount of mass inside a very small volume. And that's the proof of a black hole.
At the Keck Observatory in Hawaii, which houses one of the largest telescopes in the world, Ghez began using a groundbreaking technology called adaptive optics, which brings into focus faraway objects.
So this is without adaptive optics. This is what you would see. In this big square, there's nothing. We turn adaptive optics on, and you see the stars. This region contains the stars that provide the keys to our experiment. So we want to watch how these stars move.
Gez noticed that there was a large cluster of stars orbiting around an invisible object at the center of our galaxy. And they were moving at an unusually rapid rate.
So we can actually see these stars that are really close to the center, and we can watch them go around. Those stars go around the black hole just the way the planets orbit the sun. The orbits tell us where the black hole is, so it's located right where the star is. That's the center of our galaxy. And the details of exactly how fast these stars are going around and how tight the orbits are tells us the mass of the black hole, which we think today is 4 million times the mass of our sun.
For Gez, confirming that a supermassive black hole indeed exists at the heart of our galaxy was like summiting Mount Everest.
It was incredibly exciting to discover the supermassive black hole at the center of our galaxy, simply because it was a question we had set out to address. The question, is there a supermassive black hole? We could design an experiment that actually got at it.
Astrophysicist Andrew Hamilton says death by a supermassive black hole would be much different than by its smaller stellar mass relative.
If you want to go and be a tourist and have the ultimate experience of falling inside a black hole and finding out what's really there, go visit a supermassive black hole. Much better idea.
Unlike a stellar black hole, which would rip you to shreds before entering its deadly vortex, a space explorer could actually experience free-falling inside a supermassive black hole.
Inside a supermassive black hole, it turns out that even though the black hole is more massive, it's also much larger in size, and that means that the tidal forces are weak enough that you could pass through the event horizon and fall deep inside the black hole without being tidally torn apart. But deep down inside the black hole, the centrifugal force of the rotation of the black hole provides effectively a repulsion. If there's any matter at all inside it, then stuff that's falling in will tend to collide with stuff that's trying to get out. And the result of that collision of energies is an unimaginably chaotic maelstrom of super hot, dense plasma. And in that case, your fate is that it can roast you.
So how close would space travelers have to be to get sucked into a supermassive black hole in the center of a galaxy?
For a supermassive black hole, you would have to be about 1 million to 1 billion miles from the black hole to feel its influence.